This is video, it's problem number 8 on your acid base sheet. It is a strong base with a weak acid titration. Strong base, weak acid. So here's our weak acid here, propanoic acid. And our strong base was sodium hydroxide, so just the OH negative is all we need to show. Okay, so this is a reaction that's going to happen. Gives you the Ka value for our weak acid. 25 milliliters, 0.4 molar. Going to titrate it with this, and it's a 0.3 molar solution. So let's finish out the equation here. Obviously the acid's going to give there, so we're going to get H2O plus C3H5O2 negative. So remember, that is a weak base, and it is the conjugate base of this weak acid. So I immediately sometimes go ahead and figure out the Kb for that, so I know what the Kb is going to be for later times. So remember, this Ka times Kb is 1 times 10 to the negative 14th. So our Kb ends up being 7.14 times 10 to the negative 10th power. So I know we're going to need that. So if you think about this reaction at the beginning, so if we sketch our titration curve, at the beginning we have a weak acid there, so our pH is going to be a little bit lower, and we can figure that pH out pretty soon. As we start adding base to it, our pH is going to start rising pretty dramatically, and then at the end we're going to have only weak base present. Okay, only weak base present. So our pH should finish, since we're going to have a weak base at the end, our pH should finish somewhere above 7. Okay, somewhere above 7. So our equivalence point will be above 7. We'll talk about the indicators we use for that pretty soon here. So I want to know what's the pH starting halfway to the equivalence point, at the equivalence point. So our starting pH, so remember at the beginning all we have is this. All we have is the weak acid. So we can do our Ka, 1.4 times 10 to the negative 5th equals, remember, it would be concentration of, if we do our equilibrium expression, it's going to split into H plus C3 H5O2 negative. So remember, this is before we add any base to it at all. So Ka equals this concentration times this concentration, so we can do x squared all over our initial concentration, which is 0.4. So we can go 0.4 there. Cross multiply, take the square root. Remember, in this case, x is your concentration of H plus, because it is weak acid, and it is 0.00236 molar. Take the negative log of that. pH is 2.62. So there's our starting pH. So we're starting off at a 2.62 pH. Obviously, as we react this, it's going to go up. Now remember, this only dissociates so far, and then it stops. It's a pretty small dissociation, but this reaction will keep going because as this dissociates, the OH negatives are going to react with H plus. So these keep getting removed at H plus. So remember the Lachat's principle. If we keep removing H pluses, this will keep shifting this direction until this is gone. Okay, so the OH negatives will remove the H plus, so we're going to keep the reaction going forward. At half neutralization, okay, at the halfway point, half neutralization. So remember what I told you before, the pH at half neutralization equals the pKa, or POH equals pKb. In this case, it would be the pH equals the pKa of this acid. So the pH, and at half neutralization, remember at half neutralization, we still have some of this not reacted. There's still half of these moles unreacted. However much of this we have added has reacted. So all we have present still is our weak acid and some weak base that's been formed in the reaction. So our pH equals our pKa. So remember, pKa is the negative log of the Ka, which is 1.4 times 10 to the negative 5th. So our pH would be 4.85 at the halfway point. So we've risen just a little bit from our 2.62 up to our 4.85 at the halfway point. Okay. So now at the equivalence point. So remember, equivalence point does not mean a pH is 7 unless you're doing strong acid, strong base. Equivalence point means, in this case, equal moles of this and equal moles of this. Okay, we've done equal moles of them. And then those would all be reacted. So at the equivalence point, all we have present is the weak base. Okay, so first of all, let's do a little MVMV. So we have 25 milliliters of a 0.4 molar solution equals a 0.3 molar solution. What would the volume be there? Okay, so if we do that, it'd be 0.033 liters of NaOH. 0.033 liters, or 33 milliliters. So this is 33 milliliters. I guess that's how I did it in as milliliters. So we're going to use 33 milliliters of that at the equivalence point. That would be equal numbers of moles. Right? So these have all reacted. These have all reacted, and we have only weak base present. Let's figure out how many moles are here, or how many moles are there. It'd be the same number of moles reacted. Okay, everything's in a 1-to-1 ratio here. So our moles here, we have 0.4 moles per liter times 0.025 liters. So that would be 0.01 moles. 0.01 moles. So what that means is we used 0.01 moles of weak acid. We used 0.01 moles of weak base, of strong base, and we produced 0.01 moles of our weak base in the reaction. So remember, these reacted, all we have is weak base. We have 0.01 moles of weak base. Remember, we need to know the concentration of the weak base. So our concentration of it would be, well, we used 25 milliliters of that, 33 milliliters of that. So to get our concentration, we're going to add those two together. So we have, so our concentration of C3H5O2 negative would be 0.01 moles, that's how much was produced, divided by 25 plus 33 would be 58, so 0.058 liters. So our concentration is 0.1715 molar. That's our concentration of that. So remember, for a weak base will partially dissociate according to this equation. So it's going to take a hydrogen from water, HC3H5O2 plus OH negative ions. So I can use my Kb. My Kb would be equal to this concentration times this concentration, so X times X, all over this concentration, which we know is 0.1715. So Kb 7.14 times 10 to the negative 10 equals X squared over 0.1715. I can cross multiply, take the square root. Remember, in this case, X is the concentration of OH negative ions. And I got 1.107 times 10 to the negative fifth molar. If I take the negative log of that, that is the POH, which is 4.95. 14 minus that is 9.04. So our pH ends up being 9.04 at the equivalence point. So remember, it's above 7 because we had a strong base with a weak acid.